you that you get here. It's the second day after party yesterday. Once again, congratulations. So our first guest is Diego Di Palacio from Playsoft, and he will tell us about game architecture techniques.
Okay. Hello, good morning. When I was making my presentation, I decided to use red instead because we will be talking today in the very early in the morning, so it's something that maybe can keep me a little bit more awake. So I will start talking about a little bit fast about myself to give you a brief introduction of myself. I have some experience working on console games, on 3D simulators, on PC games, mobile games, and also teaching in some universities. I am working now for Playsoft. It's a game company which is based on Gdansk. It has more than 75 developed games, more than 500 tested games, more than 300 ported games, and we are developing for mobile, web, and PC. We have some very important clients like Electronic Arts, for example, or Warner Brothers or Ubisoft. So we are working for many good companies, important companies. We are some of our games that we are developing or porting includes very well-known brands like, for example, Plants vs Zombies or Monopoly, for example. So we have or Hitman Go. We have well-known titles. So starting with the conference, I will let you know first how will be the content. So in that way you can know what to expect from my talk even before I start. So the content of my talk is, of course, I will be talking about reusable code. I will start briefly to tell why and the requirements to make reusable code. Later, I will be talking about design patterns, architecture tips. This is very common to not only using Unity, but for games in general. Later, I will talk about some techniques that are very specific of using Unity. These techniques are techniques that you can use in every game for reusing code. Later, I will talk about frameworks. These frameworks are also related only with Unity. Well, lately, at the end, I will be talking about good practices. Some of these good practices are in general programming, in general software developers, and some other are specifically to Unity. All of this is based on my previous experience. So the first thing is why reusable code? Well, because it's saving us time. We can have a robustness on commonly used features. We can have easily replaceable components, and it's easy to test. So this is the advantages to have a reusable code. So what we need before start? We first need to check the requirements of the game or the game of games or of the games that we are going to develop. This is very important because depending on the kind of games that we are making, we want to have some of other components more reusable than others. We need to balance between now and later because the time that we are going to spend now in reusable code, it will be more than if we focus only on developing a game for today and later. Because if we spend more time today developing reusable code, it will be a saving for later. But we need to balance this because otherwise, if we spend a lot of time making reusable components and it's the only game that the company has, probably if the company goes to bankruptcy because the high amount of time that we are going to waste on reusable code, it will not be worth it. We need to think twice after checking what we want to do, what we want to recode, because later we can check if the assumptions of reusable code are fine or we can use some alternatives. And lately, plan wisely. The very basic thing about reusable code is the coupling. So this is a really requirement to have a reusable code. This is the more important part. I will be I start to talk about design patterns. So this is a couple of slides per each design pattern, which is very helpful for reusable code. So the first, it's single responsible principle. That is a single part of the to program a single part of the functionality on each class to entirely encapsulated by the class, and there will be only one reason to change. If there are more reasons to change the class, we need to think twice and then try to make at least two classes. So instead of having something that is some class that you can use for everything, you can separate the class that each of these classes has a separate functionality. Why this pattern is useful? Because it's isolate functionality in order to translate the one that we needed. The next design pattern is inversion of control. So instead of having the traditional sequential flow of the game, we can have a completely a flow that is completely not aware or not using the features that we need to inject. So this functionality about injecting will be external, and then we can have the control of this external functionality coming from outside. I will give you some example of inversion of control on a framework, so it will be a little bit more clear later. This other design pattern is dependency injection. This is this pattern is very related with the previous one, and it's a way to instead of accessing, for example, a singleton, like if we need to access the sound manager, instead of declaring here like sound manager dot instance dot some functionality, we can have a public variable or even a private using dependency injection to inject from outside this singleton or this class to be that can be used inside of the class. The inversion of control with dependency injection it's giving us instead of this service locator, for example, approach, which is very similar to singletons, it will give you a class which is going to be in charge of creates a class specifically on our game, and to inject a specific service to the class. So this class can be reusable in games, in many games. This service can be reusable in many other games, and we just need to take care about this builder. This builder is the class who is going to connect between this class and the service. So this is very useful because in this class we can inject a different service. So if we want to mock a functionality, instead of injecting the real service, we can have mocked data injected to the class. Why this is useful? Because it reduces the dependency between objects with flexible system. It isolates the code at the time of unit testing, avoid the overloads of sequential flow, and the code is clean and more readable. It's useful when developing modular systems, allows a component be tested through mocking of dependencies, and the entities are loosely coupled. The next design pattern is factory pattern, and this means that the classes that are inside of our game are asking to a factory to provide some of the functionality that we are going to use inside our game. This provider, this factory, will take care of grabbing the classes or the functionality from some providers that are outside of the game logic functionality. So at the end, we can have this factory changing the providers here by some other classes. We can have some mocking here. We can even change, for example, the system of providing sounds to have another service. So we can change this easily, and the class that are inside of the game will not be even notice this change. So we have the possibility to not change everything inside of the game logic, and change the services very easily. Why this is helpful? Because it's a high implementation of the created instances. It's easy testing, adding a replacement of more classes that implement the interface. By the way, yes, this factory needs to provide an interface to the game, of course, to the game classes to access the factory, and it has loose coupling. Another pattern is singleton. This is this pattern is sometimes considered as an anti-pattern because it has the opposite effect, like coupling our system more than the coupling. But if we use the singleton in a wisely manner, it's very helpful. How can we use this in a wisely way, a singleton? Well, if you inject the singleton to the game classes instead of accessing our classes on a game, accessing directly to a singleton, it will be very useful because we can just remove this singleton and use another instance of another class to be injected in our game. So the classes inside of our game don't even notice, doesn't know anything about the provider of the services. It doesn't know if it's a singleton or if it's an instance of a class. So we can easily replace this singleton later. But it is very easily to implement for testing, for prototyping, for if you are developing in some game jam. It's really useful. So we need to take this on account if we want. It's very useful. It is a very useful pattern to use. One, because we have one shared component. The robustness is improved because everyone is going to use only one component. So this one component will be very it will be very useful for everyone. So everyone can fix and improve the component, and if it's injected, can be easily replaced and easy to use. Another design pattern is the observe and messaging patterns. So imagine that you have to in a town you have to every day go to the post office and ask, do you have some mail for me? Do you have some package for me? If you have to go to the post office every day, will be very it will take a lot of time. We are going to waste a lot of time. So it's better to just subscribe to the post office and have some guy who is going to deliver letters or packages only when there are something available for us. And if we don't care and we don't want to have these post office notifications, we can just not subscribe to this post office. In that way, our work can be focused on something else, on the game specific logic, instead of having to look if there is something in an external class. So why this is helpful? Because it supports the principle of loose coupling between objects that interact with each other. It allows sending data to other objects of effectively without any change in the subject or observer classes. Observers can be added or removed at any point of any time. Another design pattern is the entity component system. This is the design pattern that is used on the Unity architecture. So Unity is using the entity component system by default. So implementing a game or a system which is aligned to the Unity principles can be very useful. So this design principle is that we have entities, different entities, and these entities can use or not use components. So in Unity, this will be a game object, and each game object has different components. And depending on the components that we attach on a game component, it can work in some or other way. Why? Well, because as I already said, a Unity game component class is designed entirely to use components. We have a complete separation of the game state and the game logic, and we can plug and play components to make a unique entity class. Another design pattern is the state machine. This is very well known, and we have a class which have different states. If we implement some interface with very well-defined states. We can reuse easily, for example, the classes that are related with menus, the classes that are related with sound providing, with the messaging. We can have a lot of options. Why this is very helpful? Because generic states can be stated for most common systems, and shared states can be interfaced for interchanging different implementations. For example, input source. So one example is that we can easily, using this state machine, we can easily change to use the keyboard for controlling the character in our game for some controller, for example, some console controller. And it can be changed easily if both of the input sources have the same state machine and implement the same interface. MVVM pattern. These patterns are a little bit more advanced, and working with clients, I am aware that game companies that have their own engine. To say engine, because it's not an engine, but have their own implementation of reusable code in Unity. They are using this pattern or the next one most of the times because it separates completely the Unity stuff with the game logic. So this pattern and the next one is is being used by many companies who has a lot of employees and have a lot of games. To completely separate and reuse things. So this MVVM pattern, we separate the view, which is the specifically Unity components that can be seen on the screen, like all the menus and everything that can be seen inside Unity, with a view model, which is in charge of making all of the logic and to make all the controlling of the views by changing the models. The models it will contain only the data. So this is a data holders of a class that holds all the data needed for our game. Why? Well, because it has a true separation between the view and the model, increase the versatility of the views. We have a lookless view logic. So all the logic doesn't care about the view at all. So at the end, we can replace, for example, Unity to use instead another engine like Unreal or another game will be not completely straightforward, but it will be very easy at the end if we want to just remove Unity and use another engine using this design pattern. There has no duplicated code to update views, and it has a very improved testability. This is the other pattern that I was talking about, is the MVC pattern, which is a ModelViewController pattern. The difference between this and the previous one is that we have a controller instead of model view. So this controller can use and can implement the same thing in different logics, not in only one. This is very helpful because it supports rapid and parallel development. Data which updates the model can be pushed back to multiple views. Is what I was saying. Controllers provide the logic that controls what data is seen and where. This architecture is really helpful for the couple. All of these event producers to the event consumers. So these event consumers will be our classes inside of our game. And these event producers can be everything that is on the network, like the systems which provides the networking or the multiplayer functionality. So this can be services outside of the game, and using an event transport or event bus, we can inform we can provide all of the events to the specific game logic. Why this is helpful? Because remove the overload of sequential processing. There is no point-to-point integration. It's fire and forget. Enables high performance, and highly scalable systems. Okay, this is everything about the design patterns that are very helpful to the couple and to have a usable code in Unity. I will now talk about techniques. These techniques are exclusively to Unity, but are very helpful, and this is the most common techniques that are used for using code in Unity. The first one is to have compiled DLLs. So this means that all the functionality or all the methods that we are going to reuse in many other games, we can create a library, a DLL, and then plug in to another games. So we have at the end a tighter work environment. We can have inside of our game fast compilation times because it doesn't have to compile every time the DLL's functionality. We keep the code completely separated, and it's very easy to redistribute functionality. So with this, even some asset store products have this approach. So you can grab a DLL and then start using it inside of your game. Of course, the cons of this approach is that there is no source code, so there is no way to check what is happening inside of this DLL. It's a kind of black box, so we cannot fix any bugs inside if we found some. And it has a lack of flexibility because of that. So this approach is it has advantages, but it has these cons. The next approach is using Unity packages. The usage is like most of the asset store products. We can have the source code if it's not inside of a DLL, and the insertion of all of the components are made inside of the proper folder structure, because you can specify in which folder you want to have a specific functionality and specific assets. So this is the other approach. The cons of this approach is that it increase the compilation times if it's not placed on plugins folder. These methods, Unity are compiling every time if you change something inside of the reusable code. You have more code base, and there is no source control in individual scripts or components, because if you want to improve or to use another version of the same reusable system, you need to install again all the things. So it's harder to have a source control. The third one is using Git submodels. With Git submodels, this provides a lot of flexibility, because in that way we can have a model which implements the shared knowledge between projects. We have better control on individual components. We have history changes, so we can working on a project. We can see what was changed in each version. We can have a different version in different projects. So if we have a game that is going to be about, it will be released very soon. We don't want to start using a new version. So we can stay with the current version of the usable code, but other projects can start using this new version. And the fixes are shared immediately. So if someone found some bug and submit this bug to the submodel, all the games that are using this submodel will be updated with this fix automatically when you are pulling these changes from the repository. The bad things about this approach is that bad fix is easily spread, but this can be avoided with code review requirements. So if we are using, for example, GitLab, and the pools needs to have a code review for some senior developer, this can be avoided to have a bad fix which can affect all of the projects that are currently using this shareable code. It increases the compilation times if it's not placed in the plugins folder, and you have more code base. So the next part, I will be talking about frameworks. There are already made frameworks to use in Unity to have a separate code and reusable code. So the first one is EmptyTest, which is a super fast entity component system framework, specifically made for C# and Unity. This framework was made thinking on the architecture of Unity. So the guys which made this framework think about to use the same architecture. So we have two screens here about this system, and we have one entity behavior, and we are using different components, specific components on the game logic, we can easily remove even in runtime. So even in runtime, we can easily remove components from the game objects, and we can, in runtime, we can check the time spent for each of the system, and we can, on runtime, disable or enable system. For example, physics, for example, views, for example, logic. So it's very flexible, this system. So it's the good things about this system is that it's up to date. It's easily to modify the entities on runtime. It's possibility to switch on and off the system in runtimes, and it's easy to analyze the system. So in that way, we are going to notice very easily which system it's wasting more of our resources, so we can improve more easily one system. The cons is that it's not easy integration with other object-oriented programmer, because programming systems it requires to work with a paradigm from the beginning, instead of object-oriented programming, and not easy to grab for object-oriented programming developers. Well, this second, this requirement, the guys who made this framework, they are proposing some workaround, but it's not very good workaround. I think that if you want to really use this framework to make a game, you should use it in the whole game, instead of making some workaround and some weird connections between an object-oriented programming with this entity component system framework. The next framework is Strange IOC, which is a super lightweight and highly extensible inversion of control framework, written specifically for C# and Unity. By the way, all of these framework that I am mentioning here are free, are for free, so you can use it for free. There are no cost for using these frameworks. This framework is using the kind of variation of the ModelViewController pattern, so with the services included. So it uses models, view controllers, and services. The process of this system is that you have the coupled and modular code. It uses dependency injection, use a ModelViewController services pattern. You have event dispatcher, and you have commands. The cons is that it's not up to date. The last commit was made 2 years ago. It's not easy to digest, so it's complex to understand at the beginning. It's using reflection. That this is we need to see this con with in a very with very care, because it's not so bad. Use reflection, because reflection is very expensive in Unity, but we can use reflection if it's only used at the beginning, so it doesn't have any impact on the game later. So this using reflection is fine if we are using the reflection at the beginning, and it's over complex for not large projects. The next framework is UFrame, which is a MVVM framework designed for Unity Engine. And it comes with a load of features, including graphic diagramming engine that will generate code and even process some refactorings. This is a screenshot of one of the editor views. So you have the possibility to have programming with views, and all of these views will generate some code. So you can have an overview of your system in this specific code views for connecting everything inside of the framework. So the process is that it contains a visual scripting. It's easy to log the global working on the game and systems, and it has easy separate task features between programmers. So each programmer can take care of different parts at the same time. So it improves the parallel programming between teams members. The cons is that it's not up to date. So the last commit was made 1 year ago. It has auto-generated code. So it's a con because you don't control this generated code. So you need to take care about this generated code and look with very specifically to do whatever you want. It's using partial classes. So using partial classes is it's sometimes useful, but the bad thing is that you don't have all the classes functionality in one file, so it's sometimes not very good for improving or for debugging, and it's not easy to learn. The next is Inject. Inject is a lightweight dependency injection framework built specifically to target Unity 3D. Indeed, this framework is the one that we are using currently in our company, and because it is using inversion of control, we can have in some class we can have all of the classes are going to use inside of our game. It are going to use these the classes that are implementing these interfaces, and we can in this file, specifically in this file, we can easily replace what the game will use when using these interfaces. So we can replace easily all of the services to mock system very easily. So we can test. We can have a unit testing very fine, and indeed. Changing this file will not require to change anything inside of the logic of the game or on the service logic. The process that is up to date, it has allows the couple parts with highly cemented responsibilities, is use injection, conditional binding, send parenting for inert bindings, object graphs validation is in editor time, is not in runtime, so the validation of the graphs are done before you run the game. And the cons is that it's a little bit complex and use reflection at the beginning. The last option is to implement your own framework. So if you implement your own framework, it can have the advantages that is something that is really related with your requirements and can be easily even sometimes implemented. For example, here is a implementation of the observer event pattern to create a reusable code inside Unity. So we can have a Monobehaviour which implements, which have an action and have this action. All the game components can subscribe to this action, and then we can separate the code between the trigger, the game logic that are going to trigger some event, and the objects that are going to use this functionality. For example, here we have an example of some. Imagine this is from a game which is drums. So you can hit the drums with a drumstick. So you have in one hand the functionality of triggering inside of the drum, and you have the sound, for example, in some other part. So if this drum sound is listening to this trigger, you can have the sound listening for the drumstick hitting the drums, and you can also, for example, have a menu attached to the drums. For example, in virtual reality, you maybe want to have a menu attached or some other events, so you can just listening and attach your game objects to this trigger. Or this another variant of the same trigger functionality, which implements some generics. So here, for example, can be used for changing between game states. So you can have a state game state subscribing to the triggers, which trigger a change of the game state. So you can easily reuse these classes to have in a different games, because, for example, you can have a shareable code that is use a menu with sound options, with localization options, and you can probably want to have a trigger which launch the next state of the game, and the next state of the game can be dependent of the game specific. So we can later reuse this very easily to implement different game states and reuse only the game states that we want in some games. The pros of this framework is that it's completely adaptable to the game situation. It's simply and easy to manage, and it is easy to learn. if it's intended. We have full knowledge of the code, and it's a good approach for small games. The cons is that it's not tested by a community, so it's less robust. And of course, having more features, it consumes more time. Okay, so I am going to talk now about the good practices. So one very important practice is to have on the assets meaningful names and a good folder organization. Maybe this is common sense, but it's very important. If you later want to reuse code, it's very important to have everything well organized to be easily moved from one project to the other. The second is use cache server. So if you enable the usage of cache server inside Unity, which is now for free, you can switch very easily between platforms. If you are, for example, having a game which will be developed for iOS and Android, every time that you switch between one platform to the other in the editor, it will recompile, and it will take a lot of time of recompiling all assets if you are not using this cache server. If you are using this cache server, you can easily switch between platforms, and the times will be very fast. And it reduces the importing and compilation times of other developers, which are joining to the project. So these other developers can use your already compiled assets from the source code, from the cache server. Sorry. In Unity Editor, it's very important to use very strongly typed specific references in the inspector. So if you know that the thing that you are going to use inside of one class will be a sound, for example, yes, a sound listener. You need to declare this a sound listener, not as a game object, because this can have runtime errors instead of compiler errors. So it's better to have compiler errors because are more controllable, and it's easy to reuse later. The hierarchy in editor should be completely unrelated from the code unless it was created by code. So don't use get components in children or get components in child or find components in children unless you create the hierarchy by yourself in code. This improves the reusability. Inside of Unity scripting, replacing public members to private for enforcing the coupled classes is very useful. If you want to assign these private members inside of the Unity editor, the only thing that you need to do is to use the serialized field attribute, and even if it's private, you will be able to assign inside of the Unity values or drag and drop components. And this is very helpful because the other classes cannot access to these private variables. It's important, or it's good use events instead of coroutines, because coroutines are loops that are all the time running, and events the classes are not doing anything, are just waiting, and if something happens, will be notified, and then it's wasting less resources. So this is using the Hollywood principle, which is don't call us, we will call you. So the classes needs to be not aware of what is happening outside. So if one class is going to use some system or needs to have some information from some other system, needs to wait for this other system to be notified instead. About Monobehaviour, get component with interfaces, it's really helpful. So instead of coupling your classes with specific implementations, you can couple your code with specific interfaces, and in that way, it's going to be easily to remove and to replace some classes which implement the same interface. Remove listeners on disable to avoid dangling references and being garbage collected properly to have a better managed of the memory inside Unity. In general, programming is the coupling with when possible. I already mentioned it, but I mention it again because it's really helpful for coding reuse. Compile errors are better than runtime errors, and small classes with a single responsibility. I already mentioned this at the beginning, but it's worth it to mention it again. Use a meaningful names and proper comments, and only if they provide additional and useful information. So you don't need to put any comments that are describing the same that the name of the class or the name of the field or the name of the property is already telling you. You need to use comments when some method has a specific complex way of doing things, or a class, or to explain a little bit more of what is happening inside of a method, to remember yourself in a couple of months that you are going to try to debug something inside of this method or inside of this class, or to explain to a future developer what is happening inside of this class if the class is doing something complex. So this is very important to have comments, but only if it's necessary. The usage of interfaces. So usage of interfaces for encapsulation. Think about testing needs of the project for usage of these interfaces, and tests can be reused also. So you can reuse the test even if you are using these interfaces. And my final advice is don't abuse the usage of these techniques. So these techniques sounds to be very nice and very helpful. But if you are, for example, making a game in a game jam, it not make any sense to think about how to reuse code, because you will have a limited time to develop this specific game. So not all of the code that you want to create for a game you will be reusing in some time after. Indeed, more of the code that you are working on a game specific in a game specific logic will not be reused anytime. So you need to think twice which techniques or which architecture you want to implement, and be really aware of that you are going to reuse or not this technique. So that's the end of my presentation. Thank you very much.
Thank you for presentation. I have two questions about your first part, and I will ask it together if it's connected, if you don't mind. First of all, you described patterns like solid programming, factories. It's like well-known patterns for general programming. MVC is using, it's like now mainstream in creating web application. And I want to ask if there is specific for applying these patterns for game development, because it's a little bit different than, for example, a web application, yeah? And the second question, do you use some specific patterns for game programming? I know there is a book like Robert Nystrom, Game Programming Patterns. Do you use something from there? Thank you.
Yes, well, it's a very interesting question, and well, these patterns, of course, are made for software development, and some of them have a kind of overload if you are using on game specific needs, but are being used on many companies, and more if you are working in a company which you will reuse the code in many other games. So all of these patterns that I described, I saw the implementations of these patterns specifically on games, and it's providing a good trade between the usability, the optimized way of doing things, and the reusable code. You need to take on account that in a game, more or less the 8% of the code, 80% or even 90% of the code is not sensible to be optimized. So you don't need to care too much about all of your code to be optimized from the beginning, because it will be optimized enough to run on the device, on the target device. You need to just take care of this other 10%, but for the other 90%, you can implement some design patterns, which are not, one of these cons is that are less optimized, but at the end, the trade-off between having some really very optimized and the advantages that you have in a reusable patterns is worth it. It's worth to use it. So my advice is to not use design patterns which are going to kick or to reduce the optimization in the parts of the code that you are doing very frequently, that can impact in the user or in the player experience. So I don't know if I answered your question. Okay.
I have a question.
Okay. Yeah.
What do you think about using send message and anonymous methods? Because there is a dispute in our company, I would like your opinion about this.
Yeah, well, send message, the specific send message method from Unity, it's not the best way to go, because you are not using this message. You cannot control a very strict way of the exact interface which needs to be implemented. So it's less robust in one part, and in the other hand, it costs more. So instead of using send message, I can recommend in Unity to use the event and observer pattern to specifically implement some interfaces and to use this interface instead. So it's my recommendation. But of course, in my previous comment, not all the game parts are really important to optimize. So if you are developing something that doesn't need to be really optimized on at least on this send message methods, or in the methods that are sending message, you can implement it. But you need to be aware that it will cost more and it will be less robust.
The last one.
Hi. On the first and the second framework you were describing, you said in their pros that they have commands. What was that?
Yes, commands. It's a kind of implementation of an object of a event-driven functionality. So you can, instead of sending a small message inside of the event dispatcher, you are sending a command. A command can be a sequence of instructions. So instead of sending a specific object from one class to another, you are sending a sequence of instructions. So a command can be first run the start sequence game, then load the game objects, and finally instantiate the character, for example. So this list of things that needs to be done, it can be encapsulated on a command. So a command is it's a kind of way of encapsulated method calls.
Okay, thank you very much. Huge applause once again.